So the next part of this topic is the application of Hess's law. And Hess's law, we're going to look at the enthalpy change of a reaction and look at it as a breakdown of several steps. And that basically the sum is basically the summation of all the enthalpy changes of those steps is the overall enthalpy change of the reaction. Then we're going to apply Hess's law to calculate some enthalpy changes, calculate the change in enthalpy for using enthalpy of formation data, standardized enthalpy of formation data, and determine the enthalpy change of a reaction that is the sum of a multiple reaction with known enthalpy changes. So Hess's law. So Hess's law states that in a chemical reaction, the total change in a chemical potential energy, the enthalpy change, must be equal to the energy lost or gained by the system itself. Okay, so what does that actually look like in practice? Well, this is what it looks like. So basically, you've got A going to D, okay, which is the change in enthalpy. However, it goes through intermediate reactions. So A first goes to B, which is an enthalpy change 1, which then B goes to C, which is an enthalpy change 2, and then C goes to D, which is an enthalpy change 3 for this particular reaction. So what it's saying is that the enthalpy change, delta H, is going to be the sum of all the other part enthalpy changes, delta H1 plus delta H2 plus delta H3. So what does this look like in practice? Well, let's provide an example. So given the following values, calculate the standard enthalpy of combustion for carbon to form carbon dioxide. Okay, so these are the values here. So pause the video now and see if you can work out the overall enthalpy of combustion given those two equations there. Okay, so what you should have got was that basically you're adding the two together. So carbon plus carbon monoxide plus oxygen gives carbon monoxide and carbon dioxide, which has a enthalpy of formation, enthalpy of combustion of minus 393.5 kilojoules. Okay, it was basically adding those two together. So the carbon monoxide will cancel out because it's on both sides of the equation. So it means therefore carbon plus oxygen gives carbon dioxide with a standardized enthalpy of combustion of minus 393.5 kilojoules. Okay, so now let's look at the standard enthalpy change of formation, delta H naught F. The standard enthalpy change of formation is the enthalpy change that results when 1 mole of a compound is formed from its elements at 298 Kelvin and as a pressure of 1 times 10 to the 5 pascals. All the reactants and products are in their standard states. Okay, so it's the state they're in at those particular conditions. So for example, carbon would be a solid, oxygen would be a gas. Okay, so for example, for methane, it would be carbon plus 2 hydrogen giving methane. And for, what is that, C6H5OH, that's 6, so that's hexanol, that would be 6 carbon plus 3 H2 plus half oxygen, giving C6H5OH, which will be a solid. So you can actually use Hess's law to determine the enthalpy of formation. So the enthalpy of formation is basically the sum of the enthalpy of formation of the products minus the sum of the enthalpy of formation of reactants. And those values will be given to you in your data booklet or in the exam. Okay, so what does this look like in practice? So here's another problem. Calcium carbonate reacts with hydrochloric acid according to the following equation. Given. Okay, calculate the enthalpy change for the reaction. Okay, remembering that the standard change in the enthalpy of a reaction will be the sum of the standard enthalpy change of the products minus the sum of the standard enthalpy change in the reactants. Okay, and these are the values that you will be given. Okay, so the first thing we have to do is work out the sum of the standard change of enthalpy for the products. Okay, so you're essentially looking at the equation and looking at the products. So we've got to look at calcium carbonate, water, and carbon dioxide. You add those values together, so that gives you the sum of the change in the standard enthalpy of the products. which is minus 1476 kilojoules per mole. Okay. Then the sum of the change of the standard change in enthalpy of reactants, quite a mouthful, is going to be looking at this calcium carbonate. Here we go. And hydrochloric acid. Now times that by 2, of course, because you have 2 hydrochloric acid molecules. That will give you minus 1541 kilojoules per mole. So then we just use the equation, you subtract the products from the reactants, and you get plus 75 kilojoules per mole. Okay, so that is the standard enthalpy of formation. Sorry, it's the standard the change in enthalpy of the reaction of calcium carbon reacting with hydrochloric acid. Problem 2, calculate the enthalpy change for the burning of 11 grams of propane. And again, you're given the equation and you're given the values. Okay, so again, breaking it down, the sum of the standard change of enthalpy of the products will be, again, notice it's 3, okay, 3, because we've got 3 carbon dioxides, plus 4 times this number, because you've got 4 of them. Okay, so you get minus 2150 kilojoules per mole. And then you've got 5 times 0. Now you notice here, interestingly, that, oh look, the enthalpy formation of an element is 0. Okay, that's an important point. An element equals 0. That's an important point. And the sum of the standard enthalpy of the reactants, formation of the reactants, is minus 104. Plug the numbers in, and you get minus 2046 kilojoules per mole. Okay, we'll just rub that out. So now you have 11 grams, so you've got 0.025 moles of propane, mass over MR. So it means that you then can work out the number of kilojoules, so it will be 0.25 moles of propane times minus 2046, 515.5 kilojoules. The next thing we're looking at is the standard enthalpy of combustion. Okay, so the enthalpy of combustion is the enthalpy change that results when 1 mole of a compound reacts with oxygen, again at 298 Kelvin and at 1 times 10 to the negative, 1 times 10 to the 5 pascals. And again, all reactants and products are in their standard states. So graphite, for example, carbon plus oxygen giving carbon dioxide, hydrogen plus half oxygen giving water, and so forth. Right, so again, the change in the enthalpy of combustion will be the sum of the change in enthalpy of combustion of the reactants minus the sum of the change of enthalpy of combustion of the products. So problem 1, calculate the standard enthalpy of formation of methane given the standard enthalpies of combustion of carbon, hydrogen, and methane of minus 394, minus 286, and minus 890. Okay, and the equation is given. So the change in enthalpy of combustion, of course, will be the sum of the change of enthalpy of combustion of reactants minus the sum of the change of enthalpy of combustion of the products. Okay, so you basically just plug the numbers in from the question. Okay, so it'll be 1 times delta HC of carbon, 2 times delta HC of hydrogen, because you've got 2 hydrogens, and 1 times delta HC of CH4 or methane. So you bang the numbers in, and you should get an answer of minus 76 kilojoules per mole. Good, it's negative because you'd expect that for a combustion. Okay. So in summary, these are the 4 equations that you need to be aware of when it comes to Hess's law. Okay. We've also added the delta H of reactant here, which is the delta H of naught of reaction divided by the mole ratio. Okay, be careful when you're dealing with the moles.